Okay, so for this problem again, PV equal to nRT, and the number of moles of gas is PV over RT. And so let's calculate how many moles we have. Oh, density, okay. We want to calculate the density, so we'll calculate the number of moles per unit volume. Okay, so actually we'll do N over V, number of moles per unit volume, P over RT. And so P is 101.3 into 10 to the 3 pascals. R is 8.314 joules per mole per Kelvin. And the temperature of the hot gas is 370 degree Kelvin. So in the balloon, there is this many moles of gas per meter cube of the balloon. Okay, here's a meter cube. This is a meter cube. So in this much hot air in the balloon, there's 33 moles of gas. That's what we found. Okay. Now we gotta get the mass of this many air molecules. That'll give us the density. Okay. So now just to give you a sense for the density of cold air. Density of cold air at atmospheric pressure is about 1.3 kg per meter cube. So this much hot air should of course weigh less than that. Okay, so that's just so you have a sense for where we are headed. Okay. All right, and that many moles we have. So 1 mole of air. Mass of 1 mole of air is, so the fraction is 78% is nitrogen, so 0.78 is nitrogen, and mass of nitrogen is 40 grams, no, 28 grams. Okay, let me write it this way. Mass of 1 mole of air, that is mass, capital M, air. 0.78 moles of that is nitrogen, and 28 grams per mole, plus 0.21 grams of moles of oxygen, and oxygen has 32 grams per mole, and plus 0.01 grams, 1% mole of argon, and argon is a monoatomic gas, and 40 grams per mole. So 1 mole of air weighs that much. That's what those numbers are. Okay. 178. So 1 mole of air weighs 29 grams. See, if it was all nitrogen, 1 mole of air would weigh 28 grams. But it's mostly nitrogen, and the rest are heavier molecules, so it weighs slightly heavier. Okay? So now the density of hot air, which is what we are interested in, the density of hot air equal to N over V times, okay, and we have 32.93 moles per meter cube. This is 32 moles per meter cube, and 28.96 grams per mole. Okay. So this works out to 32.93 into 28.96, 954 grams per meter cube, which is 0.94 kg per meter cube. And as promised, this is less than the density of cold air, which is 1.3 kgs per meter cube. Okay. So the density of hot air is about 1 kg per meter cube, about 30% less. All right, you guys have earned yourself a 5-minute break, and then we'll start the lecture on